Hello, everyone. Thank you for joining the Canadian Underground Infrastructure Innovation Center Academy webinar, which is titled Managing Utilities in Complex Ground Transit. My name is Inshik, and I will be today's moderator of the presentation. Organized by the Canadian Underground Infrastructure Innovation Center, the University of Alberta, and Benjamin Media, QIC Academy offers classes, courses, webinars, and events to help further underground infrastructure educational opportunities across Canada. QIC Academy webinar happens every third Thursday of each month. So please join us for our next installment, which will be held on February 19th. And for the full list of the upcoming and past webinars, please visit at qic.ca and find more information. And here we have two important QIC in-person events, which are the Spring Summit and the Fall Summit. Spring Summit will be held on March 3rd to 5th in Mississauga, Ontario, and the topic will be about geotechnical engineering, tunneling and microtunneling, and horizontal directional drilling. And the Fall Summit will be held on September 15th to 16th in Vancouver, British Columbia, and the topic will be about pipeline rehabilitation and underground safety. And currently the registration is open for the Spring Summit. And so for more information, please visit at qic.ca and learn more about it. And I would like to acknowledge Ackerman, who is the 2026 webinar series sponsor. And we appreciate your continued support for the underground infrastructure education and innovation. And now let me introduce our today's presenters. Peng Cheng is a young professional with diverse skills in technical and project management areas of civil and utility engineering. She has experience in large infrastructure projects, including serving as the utility lead for a highway project in Hamilton and dry utility lead for the Ontario Line project. As a project engineer, she leverages her technical proficiency and leadership acumen to drive success for clients such as the Ministry of Transportation Ontario, Metrolinx, and various municipalities. Her collaborative problem-solving and inclusive communication help her achieve timely, consensus-based outcomes with diverse stakeholders. Richard Morales is the Roads and Highway Business Unit Director for Ontario's Design and Engineering team. A civil engineer with 24 years of experience, he specializes in managing large, complex infrastructure projects and delivering them on schedule. Richard excels in team leadership, project management, technical guidance, and effective communication. His expertise spans project management from planning to detailed design, including utility early advance works to maintain schedules. He drives growth and provides strategic plan vision for his group, ensuring successful project delivery while fostering collaboration and efficiency. So please welcome Peng Cheng and Richard. And now the floor is all yours.
Thank you. You start presentation?
Yes. Can you click on the slides button, Richard? You could see the slide.
Let's see. Can't see the slides here.
In the top left-hand corner, Richard, you'll see the buttons Video Bridge and then Slides. If you click the Slides button, it should be able to pull up the slides for you.
Oh, there you go. Thank you very much. Is that visible there for everybody?
Yeah, it should be all able to see it.
Okay. So good afternoon, everybody. It's a pleasure to be here. Today we're going to be talking about dirty buried utilities.
It's underground utilities, Richard.
Oh, that's right. That's right. So my name, I guess, thank you for the introduction. I'm here, and the topic today is managing utilities in complex and variable ground conditions and transit projects. Let's go to the next. Or let's, Ponchan, you already, I don't know if you want to say a few words before we get going. But
sure. Yeah, I think Justin already introduced us. So my name is Peng Cheng. I'm a senior utility designer from Arcadis. I've been leading a couple transit projects where I have learned quite a bit about the utility coordination.
Thank you. So here we're going to start with the, this is our agenda. We're going to be starting with number one, the, oh no, what are the challenges we all face?
And then we will share our AHA, the utility management framework that help us keep us out of trouble.
Then we move into a case study, number three, which is the ta-da, is a real case study as to how we did this.
And then in the end, we'll finish with the woohoo. We'll have a peek at the AI-powered future.
Thank you.
So I think I would like to mention that so all the case study we're going to talk today is actually undisclosed projects. So we will not be able to share the name, but we will tell you real examples that we have experienced. So for all the major transit projects, when we look at them, they all have same big challenges. And if you look closer, almost every one of the major issues will connect to a single core discipline, which is utilities. And the schedules can be planned into hours, but if there are unexpected utility conflict, it can disrupt many things, including relationships.
Relationships? How does that
go? Yeah, you remember when our coworkers shouted at you in front of some utility companies, you're responsible for such delay.
I remember.
And as some of you know, that even small delay can add millions in costs and months to the timeline. Even during permitting process and coordinating with all the utility owners, each of them have their own priorities and their own permitting process, and that only adds to the challenge.
Don't forget that every utility owner also believes that the asset is the most important one.
Yeah, and there are so many risks. Many of the pipes and ducts we worked around could be decades old. They are not able to handle today's construction demands. And we also have environmental factors such as dewatering. It can shift the ground and stress nearby utilities. During the construction, if you're lucky and strike a sewer line, it will cause flooding and it can trigger significant incidents. And that also leads to safety risk for workers as well as the public. Richard, do you remember that time the contractor hit a water main in a major street? It caused a nightmare, and the same guy blamed you for not being ready.
That's right. It wasn't us. It wasn't even me who did the design. It was actually a utility company that was on site. But there I was, and I was the utility lead for that specific project. And that's the way it goes sometimes. When that happens, we need to just be the grown up, show respect, and be calm. take a deep breath, listen to the concerns, and then plan your execution.
And let's don't forget about the public as well. They hate the detours, noise, and you name it. And excavation itself moves the ground. It will transfer risk directly to those buried utilities.
Thank you, Benji. And let's be real. This is a nightmare list. Is there anything good about this list?
The good things, I would say we're all in the same boat. And to be honest, it makes our job security high, right, Richard? That's what you tell people when you're recruiting.
Thank you, Benji. And that's my favorite line. It's just, we do know that it's a very busy discipline with many players, and we're serving a large segment of the public. And I'm telling you, there will always be a job for us out there.
But let's be serious. Those chaos we just talked about is exactly why we need a discipline system. Utility are in the center of the wheel, and by strengthening the center, and every elements components we spoke earlier will stay steady.
Thank you.
So
now we move to this area. Mm-hmm.
Yeah. So why do we invest so much in the utility management? This image says it all. Let's picture a deep chasm. You could picture it's like a Grand Canyon, or you could picture Rocky Mountains. So on one side, it stands the project team, which they focus on schedule, budgets, and also building the future. And on the other side, there are utility owners protecting the critical service that the public relies on every single day. And the gap between them is where the risk lives, where we have misunderstanding spark delays, we have cost climb, and we have surprise explode. But utility management isn't about taking a side. It's about building a bridge across the gap. And the bridge is made with specific material. The foundation is solid data, detailed 3D model, and open communication. The keystone that holds it all together is trust. The trust means that the project team understands the owner's concerns and will protect their assets and have a credible plan. And when we build this bridge of trust, the immediate risks, we talk about service interruption, safety incidents, or budget overruns begin to fade. And the benefits don't just stop right there. The same trust became a pathway to a stronger future. We can achieve sustainability because we created a resilient system. We also have asset preservation because we're protecting the infrastructure for decades, and also on-time schedules and budget certainty.
So now we move in. Why is all the fuss about dirt? Think of it as a giant game of Jenga. You pull out the wrong block in soft soil, and boom, the whole tower collapses. Is it a dense soil? Well, maybe you could dance on it if it's very dense. And then, so we know that soil is the amplifier. Sometimes it whispers to the utilities, but sometimes it screams at the utilities.
Speaking of screaming to the utilities, remember the old metallic water mains that are brittle and can fail if vibration or excavation moves to the ground, Richard?
Oh, I remember that. And one of the worst things is that there's no standard for it. The municipalities are not, when they developed the standards, they didn't think ahead of time, hey, later on, we're going to be doing construction here and there. And every time you move something that impacts the ground, it could impact utilities. So we couldn't find any specs. We found a few studies from the US on movement, the allowable movement for some utilities, and we made some assumptions based on those studies to extrapolate it to the project that we're working on. And then there's, I know, you know, a lot of us work in design build projects. There's a document called the PSOS, which is the public, you know, project specific output specs. It's a performance specification that it's made to indicate a contractor how to handle certain issues specifically for utilities. It's monitoring and creating alert levels that's going to come out of those PSOS documents. If there's one factor that threatens budget and schedule the most, is utilities in variable ground conditions. Compressible soils like clay react to excavation and tunneling, and they trigger ground movement and settlement. And the movement doesn't stay underground. It travels straight up into the buried utilities. They crack, they misalign them, and then physical risk turns into a project pain. We call it project pain, delays. And while we relocate or protect utilities and other expenses and emergency repairs, like jet grouting actually can also help. And that's why we invest, and we want to invest a lot of upfront geotechnical investigations as well as utility investigation. This is not academic. It's just the single best way to protect the bottom line, the timelines, and the utility owners. Soils drive the risk, and understanding it is at the heart of utility management. So in here, we have a generic image that you see a tunneling here. So this type of image comes out of tools like Plaxis or similar software that are used to understand or to predict possible ground movements. Move to the next slide.
So managing utility isn't just a single task. It's a disciplined phased process that carries us from day one into our final handover.
So we don't just show up and with the shovel and start digging and wait for the best? Hope for the best?
I don't think it's possible nowadays. I heard in the past that municipalities didn't really request SUE investigation and hope for the best when you dig and leave it all to the contractor. And that's why our utility professionals get bad reputations. But thankfully, municipalities are now more sophisticated and we request SUE investigation to be conducted ahead of time.
And SUE, what is that? SUE, is that, what is SUE? Is that SUE? What does that stand for? It sounds like I'm going to get sued for it.
You could SUE is underground subsurface utility engineer. So it's kind of, to your point, there are some truth in it. If you don't do SUE, you may get sued.
There you go.
And doing the SUE is actually the part of the phase one discovery. Here showing the slides. It's like a detective work. So you dig up utility and borehole records and then investigate the site. Sometimes it's like searching for buried treasure, except it's usually a rusty pipe.
Hey, some contractors see that rusty pipe as a treasure. So more change orders,
right.
More surprises. Yeah.
I know for them, more surprises, more change orders, and that's why we need to investigate to avoid this situation. So the next phase we're going to have is model and analyze. And this is my favorite part, as this is the part that we're going to transfer the data to make them become intelligence. So we create a 3D utility and a ground model, define a zone of influence, and predict conflicts before they happen. When we move to phase 3, which is coordination and approve, and this is where we have the technical plan meets people and politics. We work with the client management, we work with the stakeholder, we align the goal, we propose the utility management plan and secure formal approval to move forward.
So this is mostly about people, this one, right?
Yes. And in our subject case, we strategize the type of personnel we want to have as a coordinator. And based on the complexity of the project we're doing, we decide to have one coordinator per utility company. So yes, Richard, it is people, and there are a lot of people and a lot of email and sometimes a lot of coffee.
Yeah.
And when we move to the final phase, we turn the plan into action. We integrate our utility work package into the master schedule, then oversee construction, commissioning, and handover to ensure everything is built and transferred properly.
In our case, for our case study, we did prepare a very detailed sequence logic using our experience and also the contractor experience. And we identify each individual step required to obtain approvals. Then I remember that when we received the original schedule from the client, it only showed one single bar in the schedule. So this part here is when we take that one bar that sometimes is not really realistic because it's one bar that goes straight out like this, but then it may have loops, right? When we did our exercise, we came out with more than 20 separate tasks for this one bar, and they all link together in the logic. And sometimes the oversimplification on utilities and ground movements is unattainable. So we need to get into that detail. I just wanted to jump and say that at that moment. And then we move on to the next stage. So now that we talked about utility management process, we talked about the issues of ground movement. We're going to talk about how to manage utilities during construction. Having a plan is one thing, that making it work is another thing. That's where our monitoring system and response system acts as the project's central system, nervous system. It begins with the robust analysis. Using our ground and utility models, we calculate precise trigger levels, each exact millimeters of settlement for utilities and for the ground. And then we calculate the amount of strain that such a utility can handle before the action is required. This sets the rules of engagement. Next, we got tailored monitoring. There's not one case fits all. Monitoring points and methods vary by depth, by soil, and utility type. And we have to track the right signals on the right places. We're now here. And then finally is innovative mitigation. And it provides two lines of defense. The first is a proactive measure. For example, a ground improvement or jet grouting. If we know that there's going to be a lot of movement in a specific area, we go out and say, okay, is there any way to, mitigate this movement here or there? So we propose things like jet grouting. And these are applied before construction if the risk and the model suggests, failure. The second is a contingency response plan that kicks in during construction. There are sensors hit a trigger level, and a pre-approved emergency team moves instantly to contain the issue. We talked about a water main earlier, and that's exactly what happened. There was some settlement, and then water main broke. And at that for those specific studies that we went through, we determined that a metallic water main that shows a movement of 10 millimeters or more, it could break, it could fail, it will fail. So then at that point we know, okay, if the models predict 10 millimeters in this area, you know, we're not gonna go and maybe change the water main ahead of time, but if we hit, you know, 7 millimeters, 8 millimeters, somebody has to be watching and say, okay, hey, Richard, they're gonna make a phone call. And then suddenly we gotta go to the site, throttle valves, and do something so that we mitigate the damage. You could see in this image a little bit of a, you know, a device that we use for that type of measurement, and that's for monitoring. So let's move on to the next slide. Yeah.
So for successful collaboration between the project team and the utility owner doesn't happen by chance. If it did, we will have a lot more free time. And all the collaboration process begins with shared goals. From day one, everyone committed to deliver the project while protecting critical assets and the public safety. And that's the foundation of trust.
Oh, remember that kickoff meeting when the utility owner told us, just don't break my pipes and we'll just get along. And we realized he was only half joking, really.
That's why we ditch assumptions and rely on accurate data. We use advanced utility engineering and geotechnical investigation let us move beyond outdated rules of thumb.
And data alone is not enough. We need to create these 3D models, these integrated 3D models. It's a shared visual language that engineers, utility owners, even community representatives can all understand. It's a single source of truth that removes ambiguity. Showing a 3D model is like giving an underground tour without the mud.
And once everyone has seen the tour, we co-develop the plan. Instead of presenting a finished utility management plan, we build it together, resolving conflicts and designing mitigation strategies side by side.
And we keep the trust strong through the construction period with constant, transparent communication. Again, trust is the main thing that's going to hold that bridge. Next slide. Next slide. So now we're going to go through some samples of how we did in this specific project. So our secret weapon for utility tracking is the utility conflict matrix. In our case, it was our master checklist for chaos. We call it UCM, utility conflict matrix.
And we also have 3D models showing in the slides. It's like our crystal ball. We could see conflicts before we dig. And then once we get into the CIAR, which stands for Construction Impact Assessment Reports, this flow chart shows on the left-hand side is the brain of our operation. So on the right side, we have on the top, you can see the result of our investigation. We pulled everything together from different software because some team member works in Revit, some works in Civil 3D, others in MicroStation, and a lot of records were in PDF format. So we need some data ninja who could digitize and export all the information into one single 3D model software. And now we use modeling software that runs in the background and can be accessed through a web browser. And we have a video we'd like to show to the audience. So the video we just saw is a model that we built using all the borehole data we collected. It gives a clear picture of everything underground for the project, and eventually becomes a digital twin of the site's underground condition.
We worked closely with our CJV partners. So CJV stands for Construction Joint Venture. It's a design build project. And to figure out the phasing, the staging of construction of the proposed structures. There's a name for this. They call it a 4D model because it includes visuals on time. So you have the 3D visuals. When are these, for example, secant piles coming in, and then are we gonna do the west side first and the east side, and then do we need to move utilities? So all of those 4D models allow us to look at timing as well as conflicts. And this approach helped us see the full picture and identify where the potential impacts may come from. We'll go to the next slide. So with our ground and design models built, now we could start predicting the impacts. Using engineering analysis, we calculate the anticipated ground movements and establish what we called a zone of influence. This zone of influence is typically bounded by settlements. It's shown as a settlement contour line, as you can see in this image. Everything within this zone of influence has the potential of being impacted.
We then use a GIS-based tool to identify and extract every single utility within the zone of influence. We download all available data on them, like material, diameter, depth, anything we can get from the records. But records are never enough, so we proactively contact each utility owner directly to obtain their most critical piece of information, including their performance criteria. For example, what is the maximum strain their asset can handle, and what is the allowable joint rotation. And this will tell us not just where the utilities are, but also how fragile they are. And in our case, some utility owners were reluctant or didn't actually know their deformation limits. So in few incidents, the utility company took the initiative to do their own calculation and share the results with us. And that's a great example of learning from each other and working together as a team to protect important assets.
And one of the things that we learned, and we have to keep in mind when we do transit projects that require tunneling or open excavations, is a cumulative impact. A cumulative impact may happen even before we start the project. For example, if there's a condo building being built here, a lot of the times these condo buildings have underground parking, and they need to do huge excavations. So sometimes it's really difficult to assess how much the utility moved when those condos were built, or how much is the utility moved after the transit project came in and then a new condo came out and built beside it. So just keep your eye, for those of you working in municipalities, that this is also a risk, the cumulative impact of multiple developments in that area. Let's go to the next slide. So this is when we get to work quite a bit. So, you can see the flow chart moving a little bit here, right? This is the step 3 is really our damage assessment, where we do a detailed number-based analysis. We take the predicted ground movement from the models and calculate or transfer to a specific force they will exert on each utility. They include, like Panchan said, tensile strain, compressive strain, joint pull out, and rotation. We then conduct a crucial test. We compare the calculated values against the hard limits provided by utility owners. And this is what it comes in the PISOS document that we talked about. So we do all the analysis, we see how much it moved in theory, and then we compare. And this gives us a definitive engineering-based answer. Does the utility pass or does it fail? And you could see the result of this analysis here. You could see an image here that shows passed, but then you see another one that fails. In this case, you could see the strain, the maximum allowed in this table here, and you could see where they are failing. And this is part of our analysis. Okay, look, if this fails, what do we do? Do we replace the utility now? Do we need to change the entire utility, or do we concentrate on one area, or do we monitor? So those are the key decisions that are made after these. And these are things that we share with our partners, utility owners as well. So they help us find a solution.
So just want to note here that this is not just a one-time exercise. We rerun the model whenever there are design changes, shifting the zone of influence, and most importantly, when we get new higher quality data from the SU survey, we will implement that into the modeling as well to refine our models to make it to produce more precise analysis.
Thank you. If a utility passes the test, the job is not over. We, like I said, we set up a monitoring plan to check if our predictions matches what is happening on site. We have the trigger levels. An amber alert, for example, is 70% of the predicted movement. And a red alert is a 90% when it's getting close to that movement. This gives us an early warning and tells us when to follow our response plan to prevent any problems. In this image, you could see, it's hard to see, but you could see a bunch of monitoring points that we have determined are needed in relation to the proposed facility. And you could also see the contour lines here for more that shows the zone of influence.
If a utility fails, we look at different ways to fix the problem, and the solution depends on the issue. It could be jack grouting to make the ground more stable. For example, here in the map, you could see dark hatches, which represents the area that we determine that will need jack grouting. Or we could add structural support to the utility, or if needed, we reroute the utility completely. So we choose the best option based on the costs, risk, and how much it will impact the community. This slide is a CIAR matrix. It's in addition to the data that we have in the utility conflict matrix, the CIAR matrix includes construction analysis parameters and also the results. And our approach to keep the stakeholder confident and our projects on track comes down to 4 pillars. First is proactive and transparent communication. We use a clear communication plan to give regular updates, turning the stakeholder from worried bystanders into informed partners. In one of the locations, our 3D model flagged that the support of excavation wall was only 0.3 meter away from a huge brand new chamber. And as we mentioned earlier, we worried about old infrastructure, but sometimes the fresh stuff could throw a curveball to us as well. And of course, after we discovered that, we didn't keep it quiet. We brought it up right away in our regular coordination meeting with the utility owner. We shared our concerns, listened, and understood their requirements.
And that follows the next pillar as smart design changes. By identifying these conflicts early in the design phase, we can often make small adjustments to our design. For the chamber that Ponchan is spotted, what we did is we shifted the SOE wall, the supportive excavation wall, to keep a safe distance. This is the most cost-effective risk of mitigation, to change the design, preventing disruptions before they plan. But changing designs, so I'm just going to put a point, changing designs takes a lot of energy because you got to go to the architects and you got to go to the mechanic. And you say, hey, that bathroom that you have right there, you need to make it smaller. Maybe we don't need 2 toilets. Maybe we need 1. We don't tell them what to do, but that takes that conversation. It's a multidisciplinary. So it could take few weeks or months to make a design change and convince all the players on the team this is the best thing to do. In some projects, we actually moved the entire station to eliminate problems, because we knew if we don't move the station, we're going to take 4 years moving these utilities. And sometimes they don't believe it. They go, oh, but, and that's when, from my experience, architects and engineers, we're very good friends, but sometimes we got to really sit down and say, look, I know this facility works there, but let's please move it, because otherwise your project's going to get delayed, right? Okay, moving on. The third is a coordinated response. We talked a little bit about that, so I'm going to go pretty fast on it. When things go smoothly, it's real teamwork. And when things, when the design is fixed, we work with the owner to create a monitoring plan and create actions. Okay. The last one is value-driven decision-making. We want solutions that save time, money, and frustration. Sometimes a little work ahead of the front is like improving, improving the ground around a chamber pays off big time later. It makes life easier for everyone. Next slide. So now next slide too. So now we imagine a future with all the AI that's happening, that is guided not by just human planning, but an intelligent hub, a dashboard. I'm sure some people here know how to use BI dashboards. They're great. I use it all the time. It manages a lot of data, and it continues to improve with AI.
Wait a minute, Richard. Does that mean we are going to lose our job?
No. What we're gonna do, we're not gonna lose our jobs. We'll use this to our advantage. We just gotta do more projects. We're gonna have time to do more projects. I mean, they always have to be an engineer validating this stuff. So just everybody keep that in mind. And an example is that this slide here was created by AI, and you can see it's not perfect. But you imagine the prompt that we had to do to get, such a good slide. It's like it's reading our minds. Well, 50% of the pictures on this presentation are generated by AI. So I just wanted to bring that up. Thank you, Pension, for helping with the prompting, because that's one of the most important things. That's what you and me are gonna do, the prompts. Yeah. I think, at the center of this machine learning brain is constantly observing the data. We could upload patterns from past projects. We could upload signals from live construction events and everything in between. And we could also use it that instead of reporting, it could anticipate what's going to happen, spotting risk and opportunities before we could see it. The results isn't just information, it's actionable foresight. Picture a dashboard that instantly recalculates timelines, budgets, and the moment conditions change. That's just, it's the future. So this is what we see on, next few years coming up.
And it's not only for construction. In design, it also acts as as the smartest project assistant you ever had. Because once they read every report, they will never forget. They will never forget any details.
Thank you. And that's our presentation. I think we're right on the dot, the 1:45. Thank you very much. And now we'll pass it over to you. Thank you, Jason.
Thank you, Pengcheng and Richard. That was a fun and creative format of presentation. I enjoyed it a lot. And now we will move on to the Q&A session. We currently have 2 questions here, but if you have any questions while we are answering, then please type in the questions and we'll address them right away. So the first question is, are 2 ground conditions in this slide, I think the slide is about transit projects and challenges, are they different? What is the difference between them?
It's the question. Let me see if I could read the question. Oh, okay.
So it was about the earlier slides, yeah.
Ground conditions. I wonder what slide it's.
Ground conditions.
So
there are 2 ground conditions. Oh, yeah. So this is like we said, the more than 50% of the slides were generated with the AI, and they are not perfect. So this is one of the, I would say, a glitch that the AI created. They come up with 2 ground condition symbols. There are not really any difference. It mean the same thing.
Okay.
Thank you. That means people like us, we still have room for working better than AI sometimes.
Yeah, exactly.
Okay, the next question, I think that's an interesting one. Is your zone of influence only horizontal or including vertical zone of influence?
Yeah, this is the zone of influence is both. It's mostly vertical, but it's also horizontal. So, yeah, so it's a 3D generated model as well. So you take the model from a Plaxis, and then you're able to export it. So that's when we have a lot of data gurus out there that are able to transfer. And nowadays, we have a common platform where we put everything. Is it a CAP file? Is it even a PDF? Is it something? And then we bring it into a common ground. So yes, the zone of influence is a 3D model.
Thank you for clarifying that. Next question is, have you participated in any projects where water pipes were CIPP lined to increase strength before a project has started?
I've been in projects where CIPP lined. That's a solution. You know how when we spoke about settlement, right? We said the model predicts a settlement of, say, 10 millimeters or 9 millimeters, or maybe it's 11. It goes beyond. So what we've done is, okay, that's what the model says. It's theoretical, fine. Let's put a line on this pipe. Let's put a liner, and then we go back to the model and say, okay, we're gonna put a liner here, and then it'll improve the model. And that, yes, we've done it. Yeah, we've done it for all concrete. We almost tried it on a break sewer. You know, those old break sewers, built 100 years ago. We spoke about that, and they do have a lot of. They could make actually a liner for those egg-shaped sewers. So we've done it. Yes, thank you.
Thank you. I think the interest for those trenchless treated pipelines also increasing because now those technology has been there for a while. So I think people are interested in knowing how they're going to be and how to work on those lined ones or like horizontally drilled ones. All right, the next question is about AI. How easy is it to recognize AI hallucinations in utility management? Are you asking it to provide information or predictions that you can't verify?
That's a good question. I love the hallucination part. So, you know, we're kind of in the early stages. So one of the things we're doing is we're using AI to help us analyze visually in plan view. First starts with the 2D, right? So when you start at the beginning, it's 2D. So you could put a PDF or a CAP file, GIS, put it all together, and then visually we say, oh, you know, there's a pipe here in our proposed wall. So that's a conflict. So we use AI to help us identify conflicts. It could be that in one location, one station location, we found 200 conflicts. It's just data management. Because visually, you kind of get tired of looking at, you know, okay, we look at this, we look at this. So what we're doing is we're taking an AI to tell us, okay, what did you find? Let me see what you found. And then we validate it, right? We may go, what we found in some cases is that the AI or even us, we found a conflict between two existing facilities. And then we go, well, it shouldn't be a conflict. It's already there, right? It's already there. So that means it's not conflicted. That's fine. But in some cases, oh, yeah, we found a conflict. You know, we found a pipe that goes through a culvert. We found that. So that's the first step, okay? It's a big process. I know that there are some also some companies doing AI recognition of conflicts. Aerial, they use Google or aerial images, and they identify the conflict just by looking at imagery, and then they do the underground. So there's so many different ways to use AI. The one that's more useful for us is to create this utility conflict matrix, because it's a very big database, and we kind of need help developing it. So that's kind of the way we're going. But there's a lot of technologies out there and companies that are doing very smart things to identify conflicts. I don't know if I responded the question, but that's it.
I think that's a good one, because the AI definitely shows strength in those conditional assessment nowadays. They use a lot of AI, so I think it's a good example. And you get some compliments from Nathaniel and Ophir. Say thank you for your presentation and great job. I totally agree with them.
Thank you.
And the next question is, with regards to buried utilities, do you take into account pipe bedding materials as the methods, materials, and standards over the 100 years have greatly changed?
That's a good question. We found these all the time because nobody knows what they used. So we, at the beginning of the assumptions, when we put our assumptions together, we use the standards, the current standards. But if we find an old standard, an as-built drawing show us the old standards, then we use that. In lack of standards, we use current standards. And I know that's oversimplification, but then we confirm that either with sometimes we do GPR, sometimes we do some test bits to determine these things. But we know roughly that, since we've been building pipes, there's got to be a bedding. There's got to be a bedding somewhere. I've seen it in books in, early 1900s. So we always assume a bedding. That's simplified. We assume the bedding. If we don't find this in the as-built drawing, sometimes they have a little section that shows you how they built it. Then we assume it.
And I also want to just add on Richard's answer. Remember, we also mentioned that we communicate regularly with utility owners. So that's some information that they could give it to us if we encounter anything. And we also share the results we have and our assumptions with the utility owner as well. If they have any concerns, they always get back to us, and we'll take their comments into account.
Sounds good. Sometimes we look into all the books for hours and hours, but sometimes one phone call and then we ask people, then we can get information as well. All right, the next question. Will you say this method of using AI to find conflict better than the clash detection on MicroStation?
Oh, that's a great question. So no, nothing is better. All tools are used. And by the way, some clients, they want to see the clash detection output, right? So we use both. We use, and here's what happens. We create the conflict matrix ahead of time before the clash detection, because we may not have all the models. We may not have, the architects will take a long time to build the models. So we need to start going, and utilities go first. Okay, that's my motto. Utilities go first. Every project is a utility project kind of thing. So, so what happens is we find it with AI, we code it, then we run this clash detection, and it may go away. If we actually have the 3D model, it may go away later. At the beginning, we may log it as a conflict using this method, and then later on, once the models get to 60 to 90%, then we use the clash detection in MicroStation. There's no way around it, in my point of view. Thank you.
Thank you. And the next question is, what scale of projects or activities require CIAR and ground settlement analysis? I assume any type of excavation requires this type of assessment.
That's a good question. Surprisingly enough, not many projects need the CIAR. Right? Like when we're talking a small project, a municipality doing something here, something there, it doesn't require. It's a very extensive analysis, very data hungry, and it requires a lot of cash because you need to do many investigations ahead of time. So we understand there is some municipalities may not have the budget to do this, right? But any project that is a design build project nowadays, you need to do this.
Thank you. We have more and more questions.
Sorry, and to answer the next question is assume that any type of excavation requires this. There are some excavations that may not require, right? If you're excavating above the utility or whatever, you may not require these. But in my opinion, anything that goes below the utility by a meter or more, and if it's a very large excavation, you need it. Yeah. Thank you.
Thank you. Next one is asking, you showed your method for monitoring ground movement, but have you had any experience with live acoustic construction monitoring of water utilities to provide advanced notification of movement that trigger pipe failure?
Oh, that's good. That's a good one. I personally haven't used it, but I heard about it. So no, I'm looking forward to doing this.
Mm-hmm. Thank you. And I also have one question. I'm in soil related field, so I have a soil question. So you showed us a lot of those 3D modelings, and we know those 3D models need a lot of geotechnical parameters as input. So how do you obtain all those parameters? Because I know some projects, they're more readily available compared to the others. So at the project perspective, how do you collect as much as you can to provide the better outputs?
Thank you. That's a good question. It's so much data. So what we do is we go through the municipality, for example, and we dig every single project they've done in the area. So it's third party. We use a lot of third party. So it could be a developer that did this, or it could be some road work that they did. So they have a log of all these boreholes in the area. But then we also have to validate this with our own borehole plan. And so we work with the client, say, okay, we need more boreholes to, ensure that the data is correct. So in a project like the ones we're discussing here, there's thousands of boreholes. So we that's part of what Panchan said, that we need to find a lot of data. So we go to municipalities. Sometimes we talk to developers in the area because we know developers are coming along and they want, the benefit of the transit system to, for their stuff. So we tell them, okay, do you have any boreholes in the area? And we get them. We go to old approved projects. We get them. We go from EA. Way back in the EA time, some EAs go 20, 25 years ago. We find borehole data and we put them all in one single, as much as we can, one single plan. And that's how we build the model.
Thank you for your
A lot
answer.
of stakeholders, that's why, Panchan said you need many people, because you need that person going, hey, where is that? Like, did you guys do a project here? Did you guys do a project there? And then we build a database.
That's right. The real power, it's the data, but data comes from people. That's the value of communication. All right. So that's all the questions. And before we finish, I would like to acknowledge the QIC members in this slide. And thank you, everybody, for coming. And I hope you enjoy your rest of your day. Thank you.
Thank you very much.